And welcome to Maths with Raz. I am your host, Mr. Raz. Today we'll be looking at the quotient rule from differentiation. So let's crack on with it. So before we get into learning the quotient rule, you should know these well. Pause it, write them down, and then make sure you have them to refer to for the lesson. So this is the quotient rule. So hopefully you're familiar with the prime notation or dash notation. So u dash represents the derivative of u, and likewise v dash represents the derivative of v. So if we have a quotient u over v, yeah, that's how we're always labeling it. Yeah, we'll never label it v over u. It is u over v. Then the formula is to differentiate it. We need to use vu dash minus uv dash all over v squared. Yeah, so the derivative of a quotient is v multiplied by the derivative of u minus u times the derivative of v all over v squared. So let's have a butcher's. So let's do two worked examples before the examples video. So here I'm giving you question one is ECX over sine x, and we want to find dy by dx. So I'm going to label u as ETX and v as sine x. So that means we need to let u equal ETX and v equal sine x. What is the derivative of ETX? Good job. It is itself ETX. And derivative of sine x, you hopefully realize, is cos x. So now we're going to sub into the formula. So we have v a u dashed sine x ETX minus ETX cos x all over v squared. Obviously, the top factorizes. So we end up with this. Yeah. We can't further simplify it. We might choose to write the denominator as sine squared x, but that's about it. Hopefully that makes sense. Jot that down for example 2. So this time we've got sine x over cos x, and now I choose this. We can amalgamate some like stuff you know from trig and other things. Yeah. So if you haven't done the trig yet, don't worry so much about this example, or use this to inspire you to learn some more and find some of the other videos. Hopefully I've had the time to put a card on to help you find your way through my videos. Now, again, u is sine, the denominator is v, so that would be cos. Sine differentiates to cos, yeah, so u dashed is cos. However, cos differentiates to negative sine. That's important because we need that sign change here. So when I sub into the formula, I've got this cos x times cos x minus sine x times minus sine x. So those two negatives make a boom, a positive. So we end up with cos squared x plus sine squared x. Because remember, cos x times cos x is cos x all squared, which is the same as cos squared x. Now, hopefully, those that have done trig will realise that the numerator cos squared x plus sine squared x is 1. So we can write this as 1 over cos squared x. And those who've done reciprocal trig functions, you'll realise that what is 1 over cos x? Sec x. Boom. So that means 1 over cos squared x will be sec squared x. So the final answer is sec squared x. You have got to love that. Yeah, you can see all the little areas coming together, all those spices of maths. Lovely. Anyway, that's the lesson video. I'll catch you shortly for the examples video. See you soon.